Yahtzee, now we're working. Okay, I just had to restart the computer quick. Okay, so for your part one of your exam, sometimes what I do is I kind of like taking a picture of a snapshot that I have up here in a video so that when I erase it, I can come back to it rather than taking a picture of it on. But if I had everything on the board there, maybe I'm missing just a little bit. But yes, they are proceeding forward with that. You bet. Okay. Random. Okay. So let's do this. Okay, there's a couple more I need to do. And I might still not have all of them. So let's. Okay, I might. I think I have them all now. So maybe we should just go around the horn. Now we've done these already. So if you want to write them down just to help you remember, fine. A good lesson to maybe remember when you take this next step in your academic career. If the professor's writing something down, then probably it's a good idea to do that as well. But if they say, you don't need to write this down, then it's entirely up to yourself. Because we've gone over this before already. And remember, these are all inside the back cover of your textbook as well. Because in one front cover, I think, is the periodic table. Then in the back cover, it has all the organic families. So with that, maybe we're not going to have where the kernel's here. Or is the kernel here? The kernel is not here. And remember, the kernel is the abbreviation for check on learning. But so the kernel's not here. Oh, he isn't? Okay. All right, so as we look at this, okay, this one's, you said already, that's an alkene, propene, okay, and what's this one then? It's an alkyne, propyne. Now it's going to get to be a little more difficult, okay, so, Jordan, what's this one? Don't muffle under your breath what it is. That's what it looks like you're doing. Are you asking me or telling me? It's an ester. Yes. This is an ester. Okay? Okay? And the reason we look at that, here's your organic family that tells you that. Okay? Okay? Right behind you, Allie. What's this one? Are you asking me or telling me? Yes, this is an aldehyde. Okay? And one of the reasons I'm saying you probably don't need to write this down, if you look at some of your notes that you've taken in this class, you go a couple pages before that, you probably have the exact same compounds written in there. Because for some reason, I've always just done 3 carbon compounds because it just seems the most simplest that you could work with. You like that instead. See, look, the kernel showed up. No? Okay. Okay, Tom. See, I'm scrambling them up. See, you thought it was going to go up here, didn't you? Propanone, yes. So just like your aldehyde, I guess I should probably put a box around that. Okay, so here's your ketone. Now, it's important to recognize these two because they're so closely related. There's just only one subtle difference between the two. Yes, on aldehydes, your double bonded oxygen is on the first carbon, where ketone is anywhere other than the first carbon. No, you don't have to know this as propanol. Yeah. Okay. See, now it gets to be pretty simple, and we try to put these in a logical order. I could say that I did that now, but sometimes it just happens to work out that way. I'm not nearly smart enough to actually plan that far ahead so we can put them in a logical order because of these two, which one looks like it's more complex? The top one does, that's true. So, but what's this organic family? Okay, because we've got this OH group, okay, so it's an alcohol. All right, so as we proceed forward, how is this compound different than this one? Has this double bonded oxygen? I could have swore you said OH. Okay. So in this case, here's your organic family. You can just say acid, and that's fine. Yes, your OH and double bonded oxygen have to be on the end. No, that OH can be anywhere. Okay? No, it would just, I wouldn't say draw an ether. No, which I didn't put up there. How do you know you're looking at an ether? See, I thought I forgot one. Okay, so it's very closely related to that, I suppose, of an ester and perhaps a ketone, but probably more so an ester because it's a single bonded oxygen. So what we're talking about is this. That'd be the simplest ether. Okay, so when we get further down the road, yeah, not for this point. You don't have to know that as dimethyl ether, which amines and amides are not on there. Alkanes will be on there. If we don't know what an alkane is, I think we're not going to be successful in this class. Okay? Is that ponytail holder a little too tight or something? Or okay? Okay. All right. Fair enough. Fair enough. Okay. So that's part of this. I think we're just going to have one problem quiz rather. I know it says problem quiz 1, chapter 3. Um, we'll just have the the organic families, some naming, and then just a couple reaction mechanisms on there. So with that, I'd be willing to believe that the reaction part would be a little more difficult. Can we erase this? Okay. So we could do something, for instance, let's go ahead and do pentane. So, okay, so if we have some pentane here, and give me a halogen, okay, So what I would suggest it now this is just what I think you'd want to do, okay? And that is, well, if anyone comes back and watches this, you got your 5 carbons. It's not showing up very brightly on this whiteboard just because the purple. I need to change color, but just for future reference, if you think that this would help you out, this is what I would recommend when you're reacting these halogens, okay? And even when we get to water, water is not a I gotta say this, is not the symmetrical compound. I don't mean to say it's not symmetrical. It's actually asymmetrical, okay? I always got to think about how I say that. So if we're reacting this chlorine, I would suggest that you do this, okay? Now, can you write it like this? Well, yes, of course, because it's diatomic. But it's just easier to see what's happening when you put the 2 chlorines next to one another, okay? I don't see why that would be any problem. So I'm just going to rewrite this quick. I'm still going to put pentane up there. I'm just going to put it in a darker color so that we can see it. Maybe that showed up. Yeah, that showed up a little better. Okay. So now, just think if I was a spider or octopus or something, I could hold a marker in each hand rather than trying to shuffle these between these hands and. Right? What? I never. I'm curious. I've never tried that before. So, so briefly, give me a word. That's actually I've never thought of doing that. Oh gosh, the left hand's terrible. Oh my gosh. I don't think so, Jill. Anywho, back to this reaction. So, what are we gonna get? What are we gonna get? What? Okay, just elaborate on that. Is that true? Okay. Do we have a third opinion? Okay. Oh, it is, huh? Are you sure? Well, it's entirely up to you. But are you sure this is what you're gonna get? 100%. See, I like that confidence, though. Is that what we're gonna get? You got. It's good to be confident. Okay. All right. See, I really like that confidence. That's supposed to be UV light or heat. Okay. So, that's one of the things. It's easy to forget that. I mean, just think of the course of taking your ACT test. I mean, is it better to get through everything and guess if you have to, or are you just evaluated on what you get done? Okay. So my point is shoot, just think if you got when you get towards the end of that, all of a sudden you're just glancing at things, and that can happen throughout the course of an exam in college. You're going through this, and then you think, okay, I've got this pentane, I've got this halogen. Okay, I'm going to zip through this, and 9 times out of 10, you're probably going to be right. And this is, it's my point is just a simple mistake. It's just a real easy fix. Okay, so we've got these 5 carbons. Okay, and what should we do? Okay, so left or right? Okay, so this would be the most common spot. You can put it up top or below, either one, whichever one you're more comfortable with. And then that's half the answer. Then, if you can remember this, true plus HCl, but is this going to be all that you would receive from this? Probably not. That would be correct. So I'll just draw another arrow down here. Yeah. So it's kind of like what we had shown, yesterday or 2 days ago. Okay, so we're also going to get this. And then someplace other than the end. So whether it's the second carbon or third carbon, probably that one. So plus. Yeah, if you would. Yes, write both. On your problem quiz too. That's correct. Not for them, but for these, we want you to do that. Okay. So hopefully we've had enough. There'd be kind of like a plus sign, because that's otherwise if you do that, you're saying it's all one compound. That's not the case, because these form in equal rates. Yes.
Do you want the top plus the bottom if we want to add a plus sign in there?
Yes. Yep.
Is there a third one?
There is. For our practical purposes, no, you don't need to put a third one on there, because it's just going to form in rates to where, like the author said, it's about 39 and 44%. So is there going to be some on the third carbon? Probably not. I wouldn't think so, because as these electrons are looking for something to bond, it's going to grab it on the outside, and that's why this guy is probably the most common one. And then this one as well. Now that will change a little bit when we get to the alkenes. There you're going to have to be a little more specific. And that's just because that double bond breaks so easily. But we're not that far yet, so that's what we want to do as far as your reaction and mechanisms. And there's only 2 or 3 of those on there. This isn't a lot on your problem quiz, so rest easy with that. Okay, then the rest of it is, as we had mentioned, went through the organic families, and then the other part is just naming the compounds. Are you fairly comfortable with that? Okay, round the bus, good. Okay, so the rest of the time then is yours to deal with how you see fit. All right, catch you next time.